Hello grade 8s and welcome to your next lesson. Today's lesson is on exponent rules. Now there are some rules that allow us to work with exponents to kind of get to a simplified power much more quickly than in fact being able to calculate it out. Okay, and this works often when we don't have numbered bases, when we have bases that are variables or letters. But we're going to be working with numbered bases, but the rules apply in the same way. Okay, so our first rule is, or law, is the law of multiplication. Now, these rules only work when bases are the same. Now remember, the base is the big number at the bottom of an exponent or of a power. Now, this law works when bases are the same and when you are multiplying. That's why it's called the law of multiplication. And the way to get to a simplified power is actually you add the exponents, and that gives you a simplified power. Okay, so you can take two powers being multiplied and simplified into one power. So here's our first example. Notice there's a base 4 here and a base 4 here. So the powers have the same base. This dot means we're multiplying. So we keep the same base of 4 and we add the exponents. So 3 plus 2 gives us a final power of 4 to the 5th. Now, I want to give you a proof on this, right? To prove to you that this really works. So when you see 4 to the 3rd, it means that the number 4 is being multiplied 3 times. I think you recognize that, right? And then there's a multiplication, and then we have the second power here being a 4 repeating 2 times, right? 4 to the 3rd means 4 repeating 3 times. 4 to the 2 means 4 repeating twice. Now, if we look at this, 1, 2, 3, 4, 5, 4s all being multiplied together, so 4 to the 5th. So this, in fact, you can see is an equal answer or equivalent answer. So there I've just proven to you that this rule works. Let's go to a second example. Now, sometimes, in fact, we see a star that means a multiplication. So again, our bases are the same, right? We're multiplying, so we're going to add the exponents. So it's going to become 4 to some number. What would that number be? Well, that number comes from 3 plus 4. Sorry, guys. 3 plus 4, and that equals an exponent of 7, so 4 to the 7th. Now remember, a bracket next to another bracket also means multiply. Now, I see in this case, we have a base of 3 and a base of 4. So the rule does not work here. This will, in fact, not give us an answer. We cannot give it 3 to the something because bases are not the same. So we can't use the rule because bases are not the same. All right, let's look at another example here. We've got a base 9 and a base 9, and we're multiplying. So we add the exponents. So now we're thinking 8 plus some number has to equal 12, right? So 8 plus some number has to equal 12. That would mean that our 8 plus 4 equals 12. So n is equal to 4, okay? You could also go 12 subtract 8 to give you 4. Okay, so sometimes you'll be asked the exponent of the answer, and sometimes you'll be asked the exponent of part of the question. Okay, now let's look at the second rule. This is the law of division. Now again, the law of division only works when bases are the same, and of course when you're dividing. That's why it's called the law of division. Now, if you add the exponents when you are multiplying, then you would subtract the exponents when you are dividing. And this again gives you a simplification or a single power. Let's look at the first example here. Whoops, I see an error there. So, see a few errors here. Sorry, folks. Okay, so let's go to the first example. Again, we are dividing here, and bases are the same. We've got 5 and a 5. So that means we're going to subtract the exponents. You keep the same base. Common mistake is to go 5 divided by 5 to give you a base of 1, but the base stays the same. And then you're going to take and subtract your exponents, so 4 take away 2, and this is going to give you a final answer of 5 to the 2. Now again, I want to do a proof of this to show you that this works. Okay? So 5 to the 4 means 5 times 5 times 5 times 5. And now we're dividing that. Remember, a fraction can mean a divide line. And that gives you 5 times 5 on the bottom. Now, if we were to, in fact, simplify this, and we would say, okay, 5 divides by 5 to give you 1, and 5 divides by 5 to give you 1. We've got 1 times 1 times 5 times 5. So what do we have left is, 1 times 1 times 5 times 5, and 1 times 1 is 1, and 1 times 5 is 5, and 5 times 5 is 25. Now, do you agree that 25 is the same thing as 5 squared? Yeah, it is. So, in fact, this rule works. All right? You could have also taken and multiplied your 5s here and gone 5 times 5 is 25, times 5 is 125, times 5 is 525 divided by 25, and you would still get 25 in your answer. Okay? Now, let's just do another example, right? Bases are the same. We're dividing, so we're going to subtract the exponents. So 2 to the what number? Well, it's going to be 5 minus 3, which again gives us an exponent of 2. Question 3 here. This is one that's going to stump a few of you and catch you up. Okay, we've got 8 to the 5. Remember, this line means divide, and then we've just got an 8 at the bottom. Well, it looks like there's no exponent there. So you would just say 5 minus nothing is going to give you 5. You'd be incorrect because there is actually an 8 sitting here. When there's 1 8, it means 8 is repeating once. So there's an invisible 1 exponent there. So the exponent is going to be 5, subtract the invisible 1 to give you 4. So it's going to be 8 with an exponent 4. Okay? Let's look at our fourth example. Okay, 3 to some number divided by 3 to the third equals 3 to the 12th. Well, you have to think, what would this number be if we're going to subtract 3 as the exponent and it's going to equal 12, right? Because you're supposed to be subtracting the exponents. So you would actually add 3, and this would give you n to the 15th, because 15 minus 3 gives you 12. Okay, here is a final law. This one is called a power to a power law. Now, when you have a power raised to another exponent, so you're going to have a single base with 2 exponents, then the rule to get to the simplified answer is to multiply the exponents. That gives you the simplified single power. Okay? So let's look at this first example. There's our base of 2. So we're going to keep a base of 2. And you can see we've got two exponents. We take those two exponents and we multiply them together. 4 times 2 gives you 8, so that gives you 2 to the 8th. Now, I want to again do a proof for you, right? This works. Okay, let's think about this bracket. The bracket is raised to the exponent 2, so that means the bracket is repeating twice. And then what is inside the bracket? Well, that is 2 repeating 4 times. So that would be like 2 times 2 times 2 times 2. And in the second bracket, you'd have 2 times 2 times 2 times 2. And you can see that 2 repeats 4 times there and another 4 times there. So it's 2 repeating 8 times. Okay? Now, again, let's answer the second question. A base with 2 exponents, we multiply those. And 2 times 5 gives us 10, so our exponent is 10, right? Keep the same base, multiply your exponents. 0 times 2 is 0, so n is 0. Looking at the last one, you need to think 4 times what number gives you 16? Well, that would have to be 4. Now, the last part is you're going to have a combination of rules. And that means you're going to have more than one multiply or divide. So you're going to multiply and divide working from left to right. If you have a fraction question, you're going to simplify the top, then the bottom, and then divide. Okay, let's look at the first question. Same base, we're multiplying, so we're going to add the exponents. Keep the base, 9 plus 3 gives you 12. Now bring down the next part, which is divide by 2 to the 5th. Again, same base, we're dividing, so we're going to subtract the exponents, right? So 12 take away 5 is going to give you 7. So keep the same base, 2, and the exponent is 7. Second example, you're going to simplify the top. So you're multiplying here, same base, so you're going to add your exponents, keep the 5 base, 3 plus 4 is 7, and now you're going to divide the top by the bottom. So now dividing, we're going to subtract the exponents, and what do you end up with? 7 take away 7, which is 0, so our final answer is 5 to the 0. All right, ladies and gentlemen, take care.